Hey everybody, how is everyone doing? How is everyone doing? Hope everybody's having a good day. Welcome to this video on debunking the process of making an FPS game in Unity. So if you've ever tried to build an FPS game in Unity, you know just how complicated it can be. But the very first step to building an FPS game is understanding how an already built FPS game works. And the Unity FPS Sample is the very last actually open source version of an FPS game that was made in Unity. But nobody really seemed to understand exactly how it works. Nobody really seemed to understand exactly how it works. And so that's what we're going to be doing in the next few series. I'm just trying to adjust the volume over here so that the sample game isn't too loud. But yes, that's exactly what we're going to be doing in the next few series. Fully understanding how everything from the networking of this game, the sound, the audio, the graphics, probably most importantly the animation, how it all works and how it can be ported into more current versions of the Unity engine. A lot of these things do not work anymore. Unity themselves recently made a pretty bold statement about the ECS system, saying that certain parts of it will not undergo development any further. I'm not shocked. Nobody really liked the ECS system. I think it was a bit ahead of its time. I guess with computers getting not only more cores but getting faster as well, maybe it will never have its time. I don't know. I mean, look at the M1 Max and the M2 Max, mate. They really don't need ECS, I'll be honest. Intel probably will move in the same direction in the future because now there's pressure. But yes, guys, we are gonna be trying to make an effort. Did I say that? No, I meant we are gonna be fully debunking this Unity FPS sample game, fully understanding how it works. And my hope is that it helps you build your own FPS game, fully understand how you can build your own FPS game, and at the same time helps me in my own work. To be honest, that's one of the main reasons why I'm doing this series, to help me out in my own work. And yeah, so everything is gonna be broken down, like I said, in this video. Everything, not in this video, but in this video and successive videos to come. Everything is gonna be broken down, guys. Everything. Now, if there's any additional questions that you have, anything in specific that you came here wanting to know, leave it in the comment section. Leave it in the comment section. Or join my Discord in the description to get faster replies. Just ask anything you want on the Discord or in the comment section. I will reply. Any part of the game, I will reply. It helps me as well in my own projects, like I said. And so today we are gonna start off by looking at the game loops of this game. It's a pretty complicated game loop system that's running in this game. And it's important that you understand it the way I do before we move on to other parts, because it's pretty much the core of what's going on. It's pretty much the core of what's going on, boys. It's pretty much the core of what's going on. I think that's enough running around the game and playing it. Let me get out of this and we can get started with understanding how this game works, understanding how building an FPS game in Unity works. It's not the most complicated process on the planet, to be honest, but neither is it documented at all. And sometimes those two things are interchangeable, being complicated and not being documented. So let's get started. Let's jump out of this. Let's get started. This video is fully time-stamped. It's my first video that's gonna be time-stamped. So if there's anything in particular you want to know, make sure to check out the timestamps. Jump over to the timestamps. Learn whatever you want to learn in there. So I'm going to be using Rider to go through this project. It's not a big deal. You can use whatever you want. You don't even have to go through it with me, to be honest. But I will be using Rider. So the project was looked at a lot in Unity talks. Nobody really explained exactly how it works. Nobody really explained exactly what we want to know. But I am going to start from the beginning. So the very first thing that you need to understand with this project is how it boots up, essentially. That's a new term for a lot of developers. Basically because not many people have an extended boot system. Usually it's just the start and the work functions. But this game does have an extended boot system because they take advantage of asset bundles. They take serious advantage of asset bundles. And if you head over to the FPS sample into Windows and go to the project tools, you get this nice window pop up. If you didn't know this nice window existed, I do advise you watch the deep dive talks that Unity had on this sample game. If you didn't know that this window existed, because they talked about it there. In any case, if you're actually building a game, don't hesitate to download this FPS sample game and follow along with me as I look at these things. But if you open this project tools window, in the levels, this is a level loading system. You can open and serve any level you want here. If you hit serve, it puts it onto a server. The server starts running. You can build levels, assets, and all, which is part of their asset bundle system, which we will look at later, not today. And you can also start some things here. Now, what I'm interested in is if you head over to the Bootstrapper and just hit open. So that opens up the scene in Unity. And the Bootstrapper has only one game object. Keep in mind, if you go over to the boot settings, there's only two scenes in there. The empty scene is important for having something in the build settings. The Bootstrapper is important for loading the other levels. So as you can see, they do not keep their levels in the build settings. They do not keep their levels in the build settings. Now, I clearly do not understand why Unity had to do this, to introduce like asset bundles, because what they could have done instead is kept us using the build settings, but then asset bundled it anyway. But I guess for backward support, it's also quite important. Now, there's only one game object in the scene. It's called game, and it's literally the one that starts the game. Now, if I go ahead and edit this code, I just want to take a minute trying to understand exactly what's happening. There's no need to understand everything. The file is quite big. There's a lot of things in it, so there's no need to try and understand anything. But what I do want us to take a look at is the awake function, because that's where things actually get started. Now, in the awake function, there's a stopwatch and a clock system. And why these are important is for keeping time within the game. This is a networked FPS game, and you cannot always rely on Unity engine.time to tell you how long it's been since the game started. It's not always accurate. The stopwatch systems by Microsoft are a lot more accurate. That's why they have them here. I do wonder why they're a lot more accurate actually, because I thought that the stopwatch system by Unity works with them. Maybe not. Now, the important thing that I do want us to look at here is how they got their console working. So if I'm to start the game, the console is helpful. That's why it's the first thing I'm looking at, because it really does help you build the game faster. So this thing here, as I type away, I can hit help and it just shows me all the commands. Now what's happening is the console is an external script that I'm not going to go into. But in here, what they did, they run a public static function that says console.init. This starts the console. And what you can do to add functions to the console, because if I hit help, you can see there's help, wait load. What you do to add commands to the console is you run console.add command, you give it a name, and you pass in a delegate that takes in a string array. The string array are like the parameters that you can put into the console. So what I can do really quickly is if I just come in here and I hit preview, and then I type test level. What it does is it takes the test level as a parameter and immediately starts a preview of the test level. The test level is quite big. I do want to say all levels in this game are big, but they're being loaded as asset bundles, which is why they take so long. Sometimes Unity even crashes at this point, which is expected. But yeah, I will give it some time as that happens. Now, once we're out of the awake function, and it's quite nice that I started by telling you about the console, because one of the commands that's available in the console, if I'm to look for it, is this preview, right? So there's preview, there's serve, there's client, there's theme client. I had somebody the other day ask me, why isn't there an actual start function in this Game.cs? It's because it doesn't need one. So these commands here, preview, serve, client, theme client, create what are called game loops in this game. So as most of you must know, a game loop is a system, a class that has an update function. It's a class that has an update function. I guess it's not starting up. I think there's an issue with the console. I'll leave it at that because I have already been able to start the game. So what I am going to do is I'm going to open up the test level. Now watch what happens when I press play. So when I press play, the console closes, but I do want to keep it open. And what you can see is there's a bunch of code in here. What I do want to make clear is that it is running this inside the console. So it runs this preview in the console, then preview runs cmd preview, and this starts the preview game loop. So the preview game loop, or any game loop in this FPS game, is supposed to have a series of functions. It's supposed to have a start function, an update function. I believe it's supposed to have a late update function. It's an interface. Here it is. So it's supposed to have an init function, a shutdown function, an update function, fixed update function, and late update function. And this is essentially the requirements for a game loop in any game, to be honest. Usually it's only one update, but that's fine. And the server, there is a server game loop, there is a client game loop, there is a preview game loop, there's a theme client game loop, and a theme server game loop. The theme client and theme server are versions of the client and server that are meant to run on worker machines. So they're meant to run multiple copies at the same time. And the server and client, you know exactly what those do. And the preview game loop runs when there is no internet connection. The preview game loop runs when there is no internet connection. Now, in this video, we are mainly going to be looking at the server game loop to begin with. Just understanding the server game loop though will give you a good understanding of every other game loop. I will visit the other game loops just a little bit, but just understanding the server game loop will give you a pretty good understanding of all the other game loops. So if you found where this iGameLoop thing is, go ahead and hit implementations. I don't know how you do that in Visual Studio. And no, go ahead and hit inheritors and look for the server game loop. That's where our journey is gonna begin. That's where our journey is gonna begin. That's where our journey is gonna begin. Now, the question is, how does the server game loop get started? Because when the game starts, it's in this Bootstrapper mode. Not this Bootstrapper mode, but it's in a Bootstrapper mode where nothing is actually running. When the game starts, it's essentially like this. There's nothing. Nothing is actually running. The important thing though is that once you start a game loop by either typing serve and then specifying the scene, or typing client and then specifying an IP address, which is what server do I connect to, or specifying preview and then typing a scene, which is what scene do you want to preview, one of the game loops gets loaded. One of the game loops gets loaded. So inside the Game.cs, we have an update function which runs at the typical update rate that Unity is meant to run updates at. This is the update function. It does a few things up here that I don't want us to focus on at the moment. But the main thing that I want us to look at, is this right here. So it says bool init succeeded is equal to false initially. Is this the one? No, that's probably not the one. That's probably not the one. That's probably not the one. It's probably not the one. Let me just check real quick. Which one it is. Aim game loops inside an update function. Game.update for each game loop. There we go. So the one I was actually looking at is just a little bit below the one we're actually doing. Now we've got these statements here, this try catch function. I'll go ahead and just make sure it's locked off from the other code so we know exactly what we're looking out for. This code here, it looks like very small code, but it's what runs the entire game. The entire game runs in here. Now what's happening here is, we know that errors can occur in here, but we don't really want to stop the game. This game is in a very errorless state because inside the console they had activated it, but I think I disabled it. But this is, I do advise that you have this. You should either be catching the errors or pausing the game. Error pause if you get an error. In any case, we have a try catch block here, and if we're not in an error state, go through all our game loops. Game loops is an array or a list. It's a list of iGameloops, which is the other objects that I showed you that have the start, update function, whatever. And that's a list of all game loops that we've started, and run gameloop.update on them. Level manager.update is just loaded in case there's a level that's loading, so that's fine. And if we do have an error, you want to handle the game loop exception as an error. We're not going to look too far into that, but as you can see, what happens is this update thing is run every single frame depending on Unity's on update frame rate. If we look at the implementation that's maintained in the server, you can see that the server does have an update loop. It has everything that it needs to qualify as an iGame loop. Now, how do we create new game loops? So to look at that, I want us to look at the cmd_serve function. Now the cmd_serve function is called by the console when you type serve and specify a scene name. And what it does is it requests a game loop type of server game loop. Now what happens when this happens, when you request a game loop? We have m requested game loop types. It adds those and then it adds some game loop arguments. And this is important because we have to wait for the update function to actually run these things. So inside the update function, we have just above our portion here where we run the update code, we have a portion here where we run the requested game loops code. And it's just saying, hey, for everything in the requested game loop types, yeah, just make sure to try and specify a new iGame loop of type iGameLoop system.activator.create instance. So it's just creating an instance of that game loop. And if we have succeeded, init succeeded is equal to gameloop.init. Now the init function returns a boolean, which is like, did you succeed? So once we have a new game loop here, we try to initialize it with the requested arguments. And if it is successful, so if not, init succeeded. So if it is successful, we say gameloops.add. So we add it to our list of game loops. Now there is a list of game loops here, but I just do want to let you know that if you are in the editor, you can have successive game loops. You can have a server running at the same time as a client, as is the case with UNet, if anybody remembers what that is. But if you're in a build, you can only have one of those running at a time. So if I'm to comment out this code here, you can see there's a part where it says shut down game loops, but this only runs if we're not in the Unity editor. So if you do request a new game loop while you're not in the Unity editor, you will have it restart. You will have it first shut down all the previous game loops. Now if we did not initiate, if we weren't successful, it shuts down the game loops anyway, and then just let you know, hey, we have an issue, the game loop failed to start. Once the game loop is started, it's added to the m game loops, and the m game loops can run an update on it. So that's how game loops are managed. What I want us to look at now is the server game loop. Just understand how that works. So the server game loop has a lot of stuff going on in here. Of course, in this video, we're not going to look at everything. But game loops have this concept of game worlds. And the game world is essentially a component of any game loop that manages objects within that world. So it's the one that, for instance, on the client, because the client will be receiving positions of objects, the game world is the one that deals with that. I don't know why they did it like that. I understand they wanted to separate it out into classes, but at the same time they left them in the same files. So I don't know how helpful it is to have a separate class but in the same file. But it does help with the C# coding conversions and whatnot. And the fact that the game loop does have to inherit from multiple interfaces here to be able to run what it does. Now this game loop, the server game world, yeah, is of type iSnapshot generator and iClient command processor. I'm going to look into that in a minute, but the relationship between game loops and game worlds is quite important to understand, so I'm going to start by looking at that. So inside the game, now look, listen, watch this part down here very closely because it shows you where I am at the moment. So if I switch over to the game world, it shows now that I'm in the construct of the game world, yeah? So I know that as I scroll around, it's going to get confusing what's really going on. But if you watch these breadcrumbs down here, you'll be able to keep track of what's really happening. I wish I could zoom in and out on these breadcrumbs. In any case, we have the enter active state. And this runs once a client connects to the server. So what's happening in here is we have a variable at the bottom of this class, a private variable, that is called mServerGameWorld, and it's the game world that the server uses. and we initialize this game world by passing in our own game world, our network server, a list of our clients, the chat system, and the resource system, which we will look into in another video. And so once we've initialized this game world, we now have access to some interesting things: the snapshot generator and iClient command processor. Snapshot generator is simply an interface that has functions that are used to generate snapshots for the entire world. And because the server literally looks at all objects on the world and just sends them over to the clients, the snapshot generator is used for doing that. It generates snapshots of individual entities. An entity in this game is not the same as an entity in ECS. An entity in this game is a networked object. Keep that in mind. Now, the iClient command processor is used to receive commands from the clients. For instance, if the client said, hey, change my character, or hey, this is my input, the iClient command processor receives that. In contrast to these objects is the iSnapshot consumer, which we will look at while we're looking at the ClientGameLoop. States are also very important. There's a state machine in here. There is a state machine in here. And the state machine is essentially a class that takes in an enumerator. So the server can have different states. It can be in idle, it can be loading, which means loading a level, or it can be active. And active means we're playing. I'm waiting for a client to come on. Now, the state machine takes in an object of type T, which in actual sense is an enumerator, and it gets initialized by the server. Now, what the server does is in the init function, it adds to this state machine different functionality that's supposed to be called in different states. So you can see state machine.add for the server idle state. We don't want to enter. The enter function is null. And then update idle state, which lets us know, hey, are we loading a level? So this runs every frame if the server is in the update frame, is in the idle state. Once it enters the loading, it doesn't want anything, it just runs loading. Then once it enters the active, that's when we have some functionality that runs here. And then this here is very important, mStateMachine.switch to idle. So when you run this function, the enter function is called, which in this case is now. The update function starts getting called all the time, and whatever state you were in previously has its leave function called. And so that's pretty much it with the server game loop. We could have an entire video dedicated to the server game loop, but hopefully that just helps you understand exactly how it's working. The next thing that I'm going to look into is the client game loop. Now the client game loop is actually a bit longer than the server game loop. I'm not necessarily surprised by that. But in any case, the system is very, very similar. The only thing that I want us to take into consideration is the fact that the client game loop does not use a server game world. Instead, it uses a client game world, okay? And the client game world has a type of iSnapshot game consumer. iSnapshot consumer. iSnapshot consumer. iSnapshot consumer. And the snapshot consumer that it has in it is the replicated entity module on the client. So as you can see, this is an iSnapshot consumer. And this is in direct contrast to the iSnapshot generator, which generates snapshots that are then taken up by the snapshot consumer. And so that's it with the client game loop and the server game loop. That's pretty much all I can squeeze into this particular video. Hopefully this helped you understand a sort of top level understanding of how this system works. In the next video, we are going to be taking greater interest into understanding how the network server and network clients work. Now be sure to subscribe to watch that video. We are going to be taking a closer look into how the network server and network clients work. And we will be further understanding how they do things. We aren't going to look into the packaging system. That will be for yet another video. But yeah, hopefully you enjoyed this. Now listen, if you do have any questions, be sure to hit the very first link in the description to join my server to receive direct help from me. And at the same time, make sure you hit that subscribe button. We need to get to 1K here. We need to get to 1K here. And I will catch you guys in the next video. Peace out.